Right. Good day once again, good people. Now, we have already now gotten our what you call like smaller molecular components, right? Then we ended up with a cyclohexanone, right? Then our Grignard reagent, in this case our phenyl Grignard reagent, right? And our acid H+. So we know that now like this now, right? We will reassemble this to generate what? An alcohol. Then an alcohol, we will what? We will remove water, that is dehydration, using what? Concentrated H2SO4 to generate what? An alkene. An alkene, in this case, we have already seen that it is our what? Target molecule. Now, let's go and look at synthesis now. How is this going to take place, right? You see, this reassembling of our what you call like small molecular components. This is what is going to happen now, right? There we go. There's my hexanone there. Double bond O, this. The theory, we've got a carbonyl compound, right? We've got a ketone, in this case, C double bond O, the C here, the C here. This is a ketone, right? Now, what's going to happen in this case now like is that we know that in a ketone, oxygen is much more what? Electronegative as compared to what? As compared to carbon. And therefore, by inductive effect, it pulls the electron density what? Towards itself to assume a sigma negative charge, right? Becoming what? Negative. And then carbon becomes what? A positive charge. Then the one that becomes a positive charge can now be attacked by what? By nucleophiles. Nucleophiles are bringing in electrons, right? Into the system, into the electrophilic center. So in this case now, like we've got our pH, right? Then Mg plus Br, in this case, this will come over and attack at the electrophilic center. And then now like the electrons here now like are pushed towards the more electronegative what called like atom. What then do we generate here? We generate this species. There we go. There we go. This here, oxygen, 1, 2, 1, 2, and those lone pair of electrons, making this oxygen to be what in charge? Negative. Negative. Right? Then pH, there is our pH in that ring. So we have generated here an alkoxide. There we go. Close this, close this. It's our intermediate. Then we know that like now, like to balance that up, we've got our MgR what? That is positive in that case. Now, what then do we do here in this case now? Like this now reacts with H+. This reacts with what? With H+ to generate what? To generate your alcohol. This goes out to pick up an H+ species there. And then, what then do we form here now? We form our OH in that case. There we go. I'll write my pH here, doesn't matter. I will write my OH here. There's my OH, my hydroxyl. So, I have now generated my what? My alcohol. Right? Now, the next step here now like is that now like I must treat that alcohol with what? With acid. What is my acid in that case? It's concentrated H2SO4. Right? There's my H2SO4, H bonded to O, bonded to S, bonded to O, bonded to H. 1, 2, 1, 2, 1, 2, 1, 2, double bonded to O, 1, 2, 1, 2, double bonded to O, 1, 2, 1, 2. Right? Now the OH here picks up this H plus from H2SO4 as this H plus leaves behind the bond pair that it shared with oxygen. What then do I generate in this case now? I generate this structure There we go. This is my pH there. Now I've got oxygen, wanted to hydrogen, wanted to hydrogen. One lone pair now, no more two lone pairs. Look, look, look. And then oxygen becomes positive in charge, right? Plus what is a byproduct there? Plus HSO4 minus HSO 1, 2, 3, 4 minus in that case. So here, my OH here is a very bad living group. My water here is a very good what? Living group, right? Now, what's going to happen here now like is that this now leaves, this leaves because oxygen is much more electronegative than carbon. Oxygen is bearing a positive charge. Then oxygen takes away the bond pair that it shared with what? That it shared with this carbon atom. Then to generate, what do we get here now? What do we get here now? We generate a structure like this now. There we go. This is our pH. And then here, this here, carbon atom becomes positive in charge because it has lost electrons. And we have generated what there as a byproduct? We have generated water as a byproduct in that case. Right? Now, this carbocation ion can stand on its own. It's a tertiary carbocation ion. It is stable. Right? Now, in the neighborhood, I've got a hydrogen here. Right? I've got two hydrogens here in any case. Right? Now, the water. What water will do now, like, will come and pick up this proton, one of the protons there, as that proton leaves behind the bond pair that it shares to generate a double bond in that case. We generate a double bond there. This, that, this, that. Double bond is formed there. Then this is our pH. Now we have formed our target molecule. There's our target molecule. And then plus what here in that case is our H3O plus. Are you with me? Right? There's our target molecule in that case. So do not be scared of organic chemistry. Organic chemistry is easy. Organic chemistry is beautiful. Organic chemistry is fun. It needs a lot of practice. Writing down. You can't read organic chemistry like this. You need to write down. You need to draw these mechanisms yourself. You need, up until you know that mechanism, keep on practicing. Use different structures. That's the best approach when it comes to what? To organic chemistry. Right? I'll see you in the next class. Don't fear, don't fear, don't fear. Thank you.